This is part of a series on data structures. In this video, I want to talk about some more data structures that handle collections of data. This time, I'll talk about the kinds of data structures you'll see in high-level languages like Python or JavaScript. These riff off the data structures I talk about in some of my other data structures videos. Some high-level languages call lists arrays, which is a bit confusing, but we can see why they chose the name. They behave a lot like arrays in that they're ordered. They're also iterable, which matters because most of these high-level languages have a way of easily looping through anything iterable without having to manually keep track of a counter. We don't know what's under the hood without doing more research, but it's probably something that riffs off of arrays or array lists or linked lists. High-level languages are less concerned with speed and are more concerned with ease of programming, so they don't care. They figure you'll prototype in something high-level like Python, so you can try lots of things quickly. Then if speed matters, you'll implement it in a low-level language like C once you've solidified your plan, so you can make it run as fast as possible. You access data just like you would with an array, but you also access it like you would with a list. If you look at the documentation, you'll see ways to add, insert, push, pop, remove, and so on. And there's often additional built-in functionality, such as looking up indices by content. If there's something you want to do, it's a good idea to check the documentation first, to make sure you don't build something from scratch that's already part of the language. At their basic level, they work like arrays. You make an empty list with a pair of square brackets. You can make a list with stuff in it by putting stuff, separated by commas, inside square brackets. This is how arrays work in most language. But importantly, you can mix data types. So in this example, we have an integer, a string, and a float. You access data the same way with indices starting at 0. So my list 0 is 42, my list 1 is foo, and my list 2 is 6.022. If you want to edit data that already exists, you do it the exact same way as you would with an array in a low-level language. For example, I can type my list, put the index 1 in square brackets, and set it equal to bar. The result will be the same array I had before, but now it has bar as its second item. Remember, we start numbering with 0, so index 1 was the second item. Tuples are ordered data in Python. Like arrays, they're iterable, but they can't be edited. Under the hood, they're probably more like arrays than they are like lists. If you want to make a tuple, you do it the same way as you would a list, but you put regular round parentheses instead of square brackets. And you never start from an empty tuple and build it up. You have to type the whole thing in at once. But you read the data in the exact same way. So if I wanted to get the data out as separate pieces, I could do my tuple with a square bracket 0 and get 200, my tuple 1 is 215, my tuple 2 is 198. So it's exactly like an array when it comes to reading. So say I want to edit this tuple. I can try to do it the way I would an array, set my tuple at an index 2 equal to 215. If I try, I'll get a message, probably filled with much more jargon than I've got here, that tells me I'm not allowed to do that. If I want to edit a tuple, the best I can do is create a new tuple from scratch and assign it to the same variable. Why in the world would I want that? Tuples are usually used to port data around, data that doesn't need to be changed. For instance, if I want to create a mapping application, I'll deal with some online API that gives me latitude and longitude. Those can be a tuple. It's not like the intersection of 4th and university is going to move. I'll need to take that data from some online service and send it to various parts of my program. I need to draw it on a map, calculate routes, display markers, and so on. The nice thing about a tuple is that it prevents me from accidentally changing data that I don't mean to change. If I use a tuple, there's no risk that some bug in my program will move the intersection of 4th and university. A dictionary is similar to an array. It doesn't have ordered data. It's list-like in that you can add and remove items like you would within a list. But instead of indices, it has alphanumeric keys, which is why it's not ordered. But importantly, it is iterable. Any of the easy looping you can do with a list, you can do with a dictionary. You just don't know what order it's going to come out in. If you've ever seen JSON, which is a format often used for exchanging data, it looks exactly like a dictionary. JSON is short for JavaScript object notation. Objects in JavaScript are almost exactly like dictionaries in Python, but with the added ability to have functions as well as data. You make a dictionary with squiggly braces. Like lists, you can create empty dictionaries and add things to them. Or you can type them in like you would with a list. But since they aren't ordered, you can't assume they start counting at 0. You have to provide a key explicitly, which will replace the index, as well as the data associated with that key. In this example, I've got a string, a number, and a tuple in my dictionary, and each of them have their own alphanumeric key, which is represented on the left side of the colon. So the format is squiggly brace, then the key in quotes, colon, and then the data associated with that key, and then a comma, and then the next key data pair until you run out, and then you close the squiggly braces. You access the data exactly the same way as you would with an array. You just use square braces, and then you put quotes with the key inside them. So in this case, if I want to get pi out, I put my dictionary, square brace, quote, pi, close quote, close square brace, and it would give me out 3.14. JavaScript objects can do a whole lot more than Python dictionaries, but that's an entirely different topic. If they just have data and no functions attached to them, they're really similar. I hope you enjoyed learning about some of the data types available in high-level languages. See you next time.